Hi everyone, my name is Nicolas Demanjou. I'm responsible ICT and Technical Standardization at ILNAS. ILNAS is a public administration under the supervision of the Minister of the Economy. It represents a network of competencies relating to quality, safety and conformity of products and services, and its mission is to support national competitiveness. In this frame, ILNAS is the national standards body in Luxembourg, and it is conducting an ambitious standardization strategy for the period 2020-2030, aiming at encouraging the involvement of the national market in the process of technical standardization and its appropriation of technical standards. Information and communication technologies, ICT, is one of the three strategic sectors targeted by this strategy, and ILNAS, with the support of the economic interest grouping ANEG, Agence pour la numérisation et l'économie de la connaissance, carries out a specific policy on ICT technical standardization in order to address the needs of the national market. The promotion of the relevant standards and of their use is one of the objectives of this policy. In order to facilitate the access to these standards, ILNAS notably provides the opportunity to the market to consult them freely on reading stations installed across the country. One of them is based in the Lycée des Arts et Métiers in Luxembourg City. Ms. Rim Doura, project officer in the EIG ANEC, will now make you discover this reading station, presenting you concrete examples of ICT standards related to container technology.
Thank you, Nicolas. I am Rim Doura from EIG ANEC. Today, I am on the premises of Lycée des Arts et des Métiers, where our reading station is available and allows you to have access to all published standards. Thank you for having us here. During this video, we're going to talk about standards related to container technology and then show you how you can gain access to these standards. But before presenting you standards related to container technology and standardization activities, let us discover what is a container and why it is important in cloud computing domain. The presentation is divided on three parts. First, we will start by an introduction to container technology. Then, we will discuss technical standardization related to this technology. And finally, we will learn more information about standards and also the possibility to contribute to cloud computing and container technology standards. According to ISO IEC 2020-123, container technology is an isolated execution environment for running software that uses a virtualized operating system kernel. Actually, containerization is a methodology that facilitates the deployment of efficient, high-performance, high-density workloads across private, public, and multi-cloud environments. Containers represent a common option for deploying and managing software in the cloud. They are used to abstract applications from the physical environment in which they are running. Container packages all dependencies needed for the well-functioning of a software component and runs them in an isolated environment. Why do we need containers? The main advantage of containers is that they are lightweight and easy to migrate from one infrastructure to another. It helps developers easily configure and deploy their applications. There are many reasons to use containers. As already mentioned, they are lightweight. Containers share the machine's operating system kernel, so you don't need a full operating system instance for each application, and this results in a smaller container files. They are also portable. Well, a container is a package that contains all its dependencies. This means you can write your software once and run it across cloud and on-premises computing environments without having to reconfigure everything. They support as well continuous integration and continuous deployments. Due to a combination of their deployment, portability, consistency across platforms, and their small size, containers are an ideal fit for modern development and application patterns. They improve as well utilization. Containers allow developers and operators to improve CPU and memory utilization of physical machine. Here we will see what is the difference between virtual machines and containers. Containers and virtual machine represent a virtualization solution and can both improve scalability, reduce overhead costs, and standardize software deployments across multiple machines and platforms. Both can help IT teams to become more agile and responsive to business demands. However, the concepts can be confusing. A virtual machine is best described as a software program that emulates the functionality of a physical hardware or computing system. It runs on top of an emulating software called the hypervisor, which replicates the functionality of the underlying physical hardware resource with a software environment. Regarding containerization, it creates abstraction at an operating system level that allows individual, modular, and distinct functionality of the application to run independently. Actually, virtual machine enables you to run multiple operating systems on the hardware of a single physical server, while containerization enables you to deploy multiple applications using the same operating system on a single virtual machine or server. According to global market insights, container technology is increasingly adopted by European countries to modernize IT infrastructure and improve operational efficiency. Due to strict regulations protecting the data of companies operating in the European Union, many cloud and data center services providers are setting up cloud centers in Europe. This has accelerated the adoption of container technology by on-premises companies, allowing them to efficiently deploy applications to the cloud. The rapid growth in the adoption of container technology has led many standardization organizations to develop standards in this area. These standards aim to guide and propose solutions for all stakeholders involved in this technology. National Standardization Organization (ISO), which handles general standardization across all sectors. We have also IAC, which is the International Electrotechnical Commission. They are specialized in electrotechnical technology and standards. We have also ITU, which is the International Telecommunication Union, and ITUT focuses mostly on telecommunication. At the European level, we have CEN, which is the European Committee for Standardization. They handle general standardization. CENELEC, which is the European Committee for Electrotechnical Standardization. And finally, ETSI, which is the European Telecommunication Standards Institute. Actually, CEN, CENELEC, and ETSI are the three standards bodies that can create European standards, and these standards are recognized by European Union. In those large standards organizations, we have national bodies representing countries with an interest in participating in standardization activities in certain technical committee. So each country has its own national body, and ILNAS is the national body of Luxembourg and is a member of ISO, IAC, CEN, CENELEC, ITUT, and ETSI. Regarding standardization related to container technology, here we have some examples of technical committees responsible for developing standards related to container technology. Most of these standards are developed in committees related to cloud computing and software engineering due to the huge dependency between these technologies. ISO IAC GTC1 is a joint committee of ISO and IAC, which cover the field of information technology. In this presentation, I present you some standards and technical specification published in this committee, mainly from the sub-technical committee AC38 and AC7. In addition to this, I present you standards from ITUT, mainly from the study group 13 and 17. Well, the ISO IAC GTC1 AC38 Cloud computing and distributed platforms is a subtechnical committee for standardization in the area of cloud computing and distributed platforms. This subtechnical committee hosts two working groups: Working Group 3 for Cloud Computing Fundamentals and Working Group 5 for Data in Cloud Computing and Related Technology. Well, regarding the Study Group 13, Future Networks and Emerging Network Technologies. This study group is notably responsible for studies relating to future computing, including cloud computing and data handling in telecommunication networks. The Study Group 13 hosts a working party on cloud computing, which addresses four questions in its standardization work. Then we have the Study Group 17 for security, which is responsible for building confidence and security in the use of information and communication technologies. The Study Group 17 hosts a working party of service and application security, which addresses three questions in its standardization work, including cloud computing and container technology. Here we have the published standards related to container technology that I will discuss during this presentation. We have first the Technical Specification 23167, Cloud Computing, Common Technologies and Techniques. The use of cloud computing has grown. A set of commonly used technologies has grown to support, simplify, and extend the use of cloud computing, which enable the effective exploitation of capabilities of cloud services. The main technology extending the use of cloud is container technology. So, the document provides a description of a set of common technologies used in conjunction with cloud computing. These include virtual machines and hypervisors, containers and container management systems, serverless computing, microservices architecture, automation, platform as a service system and architecture, storage services, security, scalability, and networking. This document will be for primary interest to service developers in cloud service providers and to standards developers working with ISO and other organizations. Then we have the document 18384 for reference architecture for service-oriented architecture. Well, this document describes a reference architecture for SOA solutions, which applies to functional design, performance, development, deployment, and management of SOA solution. It includes a domain-independent framework addressing functional requirements and non-functional requirements, as well as capabilities and best practices to support those requirements. Actually, many solutions proposed in this international standard are based on container technology. Then we have this document that was published by ITUT, which is Cloud Computing, Framework and Requirements of Container Management in Intercloud. This document provides framework and functional requirements of container management in Intercloud. It addresses overview of container management, explains advantages of deploying containers in Intercloud, provides a framework challenges for container management, and discusses the container management functional components in Intercloud. Explains the intercloud interaction management and discusses the container migration and the intercloud container deployment constraints management. Then we have the document 3535, Cloud Computing Functional Requirements for Container. Well, this document provides the overview and the functional requirements of container in cloud computing. It describes the technical aspects of container and provides the relationship between container and cloud computing. It also provides functional requirements of containers in terms of container engine, container management system, and cloud computing to support container. It provides some security considerations, use cases of containers, and an example for illustration of a comparison between a container and a virtual machine. Then we have the document entitled Security Requirements and Guidelines of Virtualization Container in Cloud Computing Environments. Well, this document specifies a reference framework with security guidelines for virtualization container in cloud by analyzing security threats and challenges on virtualization container in cloud computing environments. The main purpose of using this framework is to ensure the reliability and stability of virtualization container in cloud computing environments. Protects virtualization container security by protecting the security of all component elements, such as user layer, access layer, resource layer, and so on. Then, it provides a security management and security services to virtualization container service clients. And for information, the SC7 related to standardization in the field of software and systems engineering is currently working in many interesting documents related to container technology through its working group 29 dedicated to Agile and DevOps. Here you find some interesting projects under the direct responsibility of SC7. We have the technical report 24586, which is about Agile principles and practices, and the second part, which is about DevOps principles and practices, and also the technical report 29110, which is about life cycle profiles for very small entities, part 5 DevOps guidelines. For your information, all published standards can be consulted free of charge via one of the following reading stations. The reading stations are spread across the country. As you can see here, they are available in read-only mode with no obligation of buy-in. I will show you later how to use these reading stations. All the published national, European, and international standards can be also purchased via ILNAS eShop in PDF format with single user or multiple user license. You can buy them in your preferred language. There is also a possibility to contribute to the development of container technology standards. In order to be involved in the standards development process, you can register as an expert in a national merit committee through which you will be able to participate in the work of the AC38, for example, which is dedicated to cloud computing and distributed platforms, and also develop standards related to container technology. For your information, ILNAS, the national standards body of Luxembourg, proposes a free registration to all its national stakeholders. The registration can be done using a registration form available on ILNAS website. As already presented, ILNAS offers various services that the national markets can benefit from. In particular, the read-only consultation of published standards using the various reading stations located all over the country. So you can consult the standard that I just described in their full details and thousands of other documents. Right here, on the premises of Lycée des Arts et des Métiers, we have a reading station. Let's have a look together on how it works. Here I am on the main page of the reading station. You can simply write a keyword or the title of the standard in the search bar. I will write, for example, the technical specification that I already presented. Then the page will return the researched technical specification, and by clicking on it, you will have more information. Like the technical committee where this document was developed, and some more information like the start of the vote on the final project, end of the vote on the final project. And obviously, we have the PDF where you can read the full content of these documents. Here we have the cover page. Then you can browse and have the detailed information of these documents. We have reached the end of the presentation. Thank you for watching. I hope you enjoyed the video.
If you have any questions concerning the presentation, or you have an interest to be part of the standardization community or to know how standards can affect your business, do not hesitate to contact us by phone or by email. We will also be happy to hear from you if you have ideas about the updates of container technology. I will also be your contact point if you are interested in standardization activities for other ICT topics, like blockchain, data center, e-learning, and so on. Also, we will be happy to have you on board.